The chemical reaction is a chemical process in which two or more substances called reagents, by the action of an energy factor, are converted into other substances designated as products. We are surrounded by chemical reactions. They take place in laboratories, but also in factories, automobiles, thermal power stations, kitchens, the atmosphere, the interior of the earth, and other ways. The new substances that are formed usually present a totally different aspect from the starting substances. During the reaction, energy is released or absorbed according to the different types of reaction. First, we have the exothermic reaction. The energy is released in the course of the reaction. Then we have the endothermic reaction. The energy is absorbed during the course of the reaction. First, we have the redox reaction, the direct combination, the chemical decomposition, the single displacement, the double displacement reaction, the acid-base reaction, the combustion, the isomerization. Finally, we have the hydrolysis reaction.
In the practice 7, we use the table of solubility to help us determine the reaction of each mixture. For example, the row of zinc sulfate has a yellow color even though it's mixed with another compound. But if you can see, the reaction of zinc sulfate and copper sulfate has a green color due to the copper sulfate column, because most of the reaction of copper sulfate are in color blue.
In this time in the lab, we learned to predict the possible results of a chemical reaction by combining two or more substances. Also, we learned how to react to different mix of chemical substances. This will help us to know which type of mixtures can be combined and which ones will not have any effect.
We learned to predict possible reactions by combining two mixtures. We observed that even though two aqueous solutions are mixed together, they can form solid compounds. Thanks to the table of solubility, we noticed that the predictions were true.
The particle was already fluently because it was on my skin and getting the exact amount of drop. Each compound in the tablet was really difficult and we had to do the one experiment and complete on time.
In our experiment number 8, medium, there are different gases. These gases have certain properties, and thanks to these properties, these substances' reactions are to certain physical phenomena. Scientists experiment with gases to define their properties and behavior, such as measuring volume, pressure, and temperature in different areas, and this leads to the elaboration of the generalized law, the law of ideal gases, for the different behaviors represented by a gas. A gas can be diatomic or monatomic, and we can know this by its ions to negative or positive charges, causing the gas to react to have a change in its behavior. In this practice gases, we work with hydrogen and oxygen, and I was able to learn the properties of these gases.
Synthesis oxygen due. Social note. Oxygen is anti-deuterium. Almost six members of this divide return to the combustion current with the oxygen. When the match was brought closer, 20 days, tubes are somewhat. No sound was heard and flame with granted volume can be seen. The reason is maximum. The flame is indication and only the steam remains in the test tube. This experiment can also be used for gas reaction with contact current, liquid and unnecessary to saturate liquid with gases and to avoid reaction in the atmosphere. The gas, when they are insoluble or very little soluble in water, can be connected on induced Intermediate which is nothing more than gradually tube inverted in a spheric figure with water.
With this practice, we learn to create a minimum amount of oxygen in order to create a flame of fire with a burnt stick. This was a very easy process, but we did take care of the steps to follow because it is very delicate and you must be patient to have success. Also, we were in other experiments to get the synthesis of O2, H2, and CO2. All of these experiments were made with the objective to learn how to create these substances.
In this practice, we learn to prepare compounds in gaseous states. We met the objective of preparing carbon dioxide, oxygen, and hydrogen. In each of the experiments, we obtained the desired results. Personally, I learned that in real life there are reversible reactions. For example, when we heat the copper and we enter air, it became black, and when administering oxygen, it returned to its original color. And the experiment I liked the most was to make the soap bubbles burst approaching the fire.